Logic, example 14. And in this we're going to discover the converse, inverse, and contrapositive of the conditional. For any conditional, there are three related statements: the converse, the inverse, and the contrapositive. So the conditional starts out if P then Q. The converse is the if Q then P. The inverse is if not P then not Q, and the contrapositive is if not Q then not P. So let's go ahead and find the truth value of each of these. So with the conditional, first of all, we have to do the not P and not Q. Sorry about that. So the not P is false, false, true, true. And not Q is false, true, false, true. So for our conditional, we know that true, false will be our only false. Everything else will be true. Okay, so for our converse, we have a true, true. We know that's true. False, true is true. True, false, we know that that is false. And false, false will be true. Okay, the not P, if not P, then not Q. So the false, false, and the false, true, we know will both be true. The true, false, we know will be false. And then the true, true will be true. All right, then lastly, let's look at the contrapositive. If not Q, then not P. So we've got a false, true. Sorry, that's not the case. False, false. So that will be true. True, false will be false. False, true will be true. True, true will be true. Okay, so if you will compare what we have here, it looks like conditional and the contrapositive are equivalent, as are the converse and the inverse. Okay, so again, let's formalize this. Looking at the results of the truth table, we can say the following: a conditional and its contrapositive are logically equivalent, and the converse and inverse of a conditional statement are logically equivalent. So let's look at example 14. Suppose a statement is true: if Jenny makes the soccer team. Let's go ahead and let S stand for the soccer team. So if Jenny makes the soccer team, then she'll have 2 games a week. Let's let G stand for games. So it looks like everything in this conditional is stated in the positive. All right? So let's see if we can write this the next 3 statements symbolically. If Jenny has 2 games a week, so it looks like we have a G, then she made the soccer team. If G, then S. If Jenny doesn't make the soccer team, so that's negation of S, then she won't have 2 games a week. So that's the negation of the G. If Jenny doesn't have 2 games a week, that's the negation of the G. Then she didn't make the soccer team. That's the negation of the S. Okay? So if we look at everything symbolically, it looks like this is our conditional, and what's logically equivalent to that is going to be our contrapositive, which is this statement here: if Jenny doesn't have 2 games a week, then she didn't make the soccer team. So example 14b gives people some problems because they're expecting everything to be like the conditional to start out with positive. So maybe we need to start looking at the opposites on our 3 other statements. So let's go ahead and write the conditional symbolically. If Tammy doesn't pass the class, so remember we write our statements in the positive. So if Tammy doesn't pass the class, not P, then she won't graduate. Implies not let's put a G there. So not P implies not G. Okay, so if Tammy passes the class, then she'll graduate. So P implies G. If Tammy graduates, G implies she passes the class, then she passes class. So P. If Tammy doesn't graduate, that's a negation of G, then she didn't pass the class. That's a negation of the P. Okay, so this looks like it is the inverse. It has the inverse form. So what is its logically equivalent? It would be the converse. So I should be looking for a G then P. So it looks like this statement here, if Tammy graduates then she passed the class, would be the equivalent. That would also be true.